Welcome back to Math Dogs. If you're new to the channel, please comment, like, and subscribe. If you have any questions, please comment down below. Today's topic is complex number operations. And we have an example of each of the different types of operations for complex numbers. Remember, we believe math is better with your dog, so call your pups. Let's get started. Problem number 75 is complex numbers. It says find the conjugate of 6 plus 4i. So complex numbers are numbers that are written in the form a plus bi. A is a real number and bi is an imaginary product. And so it says to find the conjugate of this complex number. Well, the conjugate is its difference of squares partner. So if I have 6 plus 4i, its conjugate would be 6 minus 4i. Problem number 76 is also complex numbers. It says find the conjugate of 3 minus 5i. So the same type of problem as before. I have 3 minus 5i. The conjugate is its partner in the difference of squares factoring pattern. It's going to be the opposite sign of negative. It would be 3 plus 5i. Problem number 77 is adding complex numbers. It says 8 plus 6i plus 2 minus 3i. So again, we have addition or subtraction. It's going to deal with combining like terms. In this case, I can add together my number terms, 8 plus 2, and get 10, and my imaginary products. Plus 6i minus 3i would be plus 3i. So the I acts as a like term. It makes that product a like, and so I can combine them. And so my answer would be 10 plus 3i. Problem number 78 is subtracting complex numbers. It says 2 minus I minus 4 plus 7i. So I have an additional step. I will have to distribute the negative sign to the second set of parentheses or find the opposite of the numbers in the second set of parentheses. So I would get 2 minus I. The opposite of positive 4 is negative 4, and the opposite of positive 7i is negative 7i. Now I can go ahead and combine those things that are alike. So I have the numbers 2 minus 4, which is negative 2. And I have my imaginary products. Negative I minus 7i is negative 8i. And so my answer is negative 2 minus 8i. Problem number 79 is multiplying complex numbers. It says 5 minus 2i times 3 plus 7i. So first we have to remember the definition from a couple problems ago that I squared equals negative 1. Since these are two binomials, we're going to use FOIL, first, outer, inner, last. So let's multiply. 5 times 3 is 15. 5 times 7i will be 35i. Negative 2i times 3 is negative 6i. And negative 2i times 7i is negative 14i squared. So here's where our definition comes into play. I squared is negative 1. So this would be negative 14 times negative 1, which would be positive 14. So I would have 15 plus 35i minus 6i plus 14. And now it's just like combining like terms. I have 15 plus 14, which is 29, and I have 35i minus 6i, which is plus 29i. And so my answer would be 29 plus 29i. Problem number 80 is dividing complex numbers. It says 4 minus 5i over 3 plus 2i. So the trick with dividing complex numbers is to remember there's no division. To divide complex numbers, we actually multiply by a form of 1 that's the complex conjugate of the denominator. So let's look at that. First, I'm going to put the top binomial and bottom binomial in parentheses to help focus us. And then I'm going to multiply by a form of 1, which will not change the value of the original problem. I need to multiply by the complex conjugate of 3 plus 2i. And from a couple problems ago, that would be 3 minus 2i. And I'm going to put that on the top as well so that it's 1. So now in the numerator, I have two binomials to multiply, and in the denominator I have two binomials to multiply. So let's multiply using FOIL. 4 times 3 will be 12. 4 times negative 2i will be negative 8i. Negative 5i times 3 will be negative 15i, and negative 5i times negative 2i will be positive 10i squared. But remember, I squared is equal to negative 1. And so in the numerator, this would actually be 10 times negative 1, which would be negative 10. So my numerator would be 12 minus 8i minus 15i minus 10. Now in the denominator, I'm going to multiply 3 plus 2i and 3 minus 2i, again using FOIL. And since it's a complex conjugate, the middle term should subtract itself out to 0. So 3 times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i, so these will add to 0. And 2i minus 2i is negative 4i squared. But again, I squared is negative 1, so this negative 4 will be multiplied by negative 1, which will give me a positive 4. So let's combine like terms in the numerator and combine like terms in the denominator. So 12 minus 10 is 2. Negative 8i minus 15i is negative 23i. In the denominator, negative 6i plus 6i is 0, or as some people say, it cancels out. And I would have 9 plus 4, which is 13. And so my answer would be 2 minus 23i over 13. So that's it. Example problems dealing with complex number operations. Keep working hard. Don't ever give up. If we can help in any way, just type in the comments, give us a question, and we'll be more than happy to help. And as we say at Math Dogs, you got this.